Look up at the sky. Those long, silvery wires stretching across fields and mountains, buzzing faintly on quiet days, power almost everything we do. They connect cities, farms, factories, and homes. But here's something surprising. Those endless cables aren't made of copper, the metal most of us associate with electricity. They're made of aluminum. That sounds strange, right? Copper is in our chargers, laptops, phones, and the wiring inside every wall. It has been the king of electrical conductors for over a century. But why did we choose aluminum for the biggest and most important power systems on Earth? Well, this story brings together ancient metallurgy, wartime shortages, and the surprising physics of what actually keeps our lights on. Today, we're unspooling that silver thread in the sky to uncover why the world's power lines run on aluminum, not copper. To understand this choice, we need to return to the age when copper was king. Humans have worked with copper for over 10,000 years. Ancient civilizations hammered it into tools, jewelry, and early coins. But in the late 1800s, copper took on a new identity: the metal of electricity. When Thomas Edison built the first electrical grids in the 1880s, they ran on copper wires. Copper was perfect, highly conductive, corrosion-resistant, flexible, and able to carry a lot of current through small cables. But as cities grew and power needed to travel farther, engineers noticed a major limitation. Copper is heavy and expensive. Running copper cables across hundreds of kilometers wasn't just an engineering challenge, it was a financial one. Meanwhile, aluminum was still a curiosity. In the early 1800s, aluminum was so rare that it was considered more valuable than gold. Scientists could only extract tiny amounts from its ore, bauxite. Napoleon III even used aluminum cutlery for his most honored guests. Then, in 1886, everything changed. Two young scientists, Charles Martin Hall in the US and Paul Héroult in France, independently discovered the same breakthrough: an efficient way to extract aluminum using electricity. This single invention flipped the metal market entirely. What had been precious suddenly became practical. By the early 1900s, aluminum was cheap, abundant, and increasingly attractive to engineers. 1/3 the weight of copper, doesn't rust, easy to shape, and conducts electricity well enough for long distances. That last part would prove crucial. Transmission lines don't just carry electricity, they must span rivers, valleys, and mountains, sometimes for hundreds of meters between towers. The heavier the cable, the more it sags under its own weight. More sag means stronger, taller, more expensive towers. Here's where aluminum shines. Copper conducts electricity better, about 60% better in fact. But aluminum is more than 3 times lighter. So if you compare equal weights of the two metals, aluminum can carry the same amount of electricity while putting far less strain on the towers. That meant cheaper structures, longer spans, and lower costs, exactly what massive national grids needed. Before World War II, copper was still the default for power lines. Aluminum was used occasionally, but copper ruled. Then the war began. Copper became essential for weapons, radios, vehicles, and military communications. Demand skyrocketed, supply dropped, prices soared. Utilities urgently needed an alternative, and aluminum was already being mass-produced for aircraft. During the 1940s, engineers began replacing copper transmission lines with aluminum. When they saw that aluminum worked just as well for long-distance grids at a fraction of the cost, the switch became permanent. By the 1950s, aluminum had become the global standard for overhead power lines. Today, the silver-colored cables you see overhead aren't pure aluminum. They're usually ACSR conductors, Aluminium Conductor Steel Reinforced. Inside is a strong steel core that gives the cable strength and prevents stretching. Around it are layers of aluminum that carry the current. The steel keeps the line from snapping. The aluminum keeps the line light and efficient. Engineers even use more advanced versions today: aluminum alloys, heat-resistant aluminum, and carbon fiber cores designed to carry more electricity with less sag. Those shimmering silver lines on the horizon are still evolving. So why not use aluminum inside our homes? The answer is scale. For short distances, inside houses, appliances, and electronics, copper still wins. Copper conducts better, forms stronger, safer small connections, and doesn't loosen over time, handling more heat in tight spaces. Aluminum, especially in small wires, forms oxide layers that increase resistance, can loosen at connection points, and is less safe for compact, high-power devices. That's why our homes use copper, but our power grids use aluminum. Here's the bottom line. A ton of copper costs around 3 times as much as aluminum. Copper is heavier, requiring stronger towers, and aluminum performs just as well for long distances. When countries build thousands of kilometers of transmission lines, that cost difference becomes enormous, often billions of dollars. Simply put, copper is better, but aluminum is smarter. As the world builds more renewable energy, solar deserts, offshore wind farms, and continent-wide power grids, the need for long and efficient transmission lines keeps growing. Aluminum, being light and affordable, is perfectly suited for this future. Modern research is pushing the limits even further. Composite core conductors, heat-resistant aluminum alloys, ultra-low sag lines, and carbon fiber reinforcements. Those shimmering silver lines on the horizon are still evolving. So next time you drive under those sweeping silver wires, remember, high above us, it's aluminum quietly carrying the heartbeat of our modern world. We often think of copper as the hero of electricity, but in the sky, it's aluminum doing the heavy lifting, or perhaps the light lifting. From a metal once rarer than gold to the backbone of our global power grid, aluminum has traveled one of the most remarkable journeys in industrial history. If you enjoyed discovering the hidden story behind something ordinary, don't forget to like, share, and subscribe to Simple Things, Surprising Histories. Because there's always more to uncover, one simple thing at a time.